So the rules in multiplication and division are a little bit different than they are for addition and subtraction. In fact, when we were looking earlier at a video about associative, commutative, and distributive properties, you have to be careful. The commutative and associative properties only work for multiplication and division alone or addition and subtraction alone. You can't mix them up for those two properties. Okay? You have to be careful about that. You can associate addition problems or subtraction problems. You can there's a commutative property of addition and subtraction. There's also associative and commutative properties for multiplication, but you can't put multiplication addition together in the same problem and have the same kind of associative and commutative properties. Okay, got to keep those kind of separate. The distributive property looks at how multiplication distributes to addition or subtraction, or division distributes to addition and subtraction. Okay, you have to keep all that straight. It's important to understand that what you can mix and match and what you can't. Okay, so the same is kind of true for rounding off. There's a set of rules for rounding off that apply only to addition and subtraction. That set of rules does not apply to multiplication and division. There's a separate set of rules for multiplication and division. Okay, you with me? All right, so what we're going to look at now is how that works in the kind of problems we do in chemistry. All right, so let me give you this problem. There are 44.095 grams of carbon dioxide in 1 mole of carbon dioxide. So how many moles of carbon dioxide are in 12.25 grams? All right, so there's two things you need to know. Two things by reading this problem you need to be able to figure out. So the two things you need to know. And the first of those things is you need to know what the starting amount is. And then you also need to know what equality statement, or later on in this class it'll be plural. There'll be more than one equality statement. And you can figure out both of those by reading the problem. Okay, this is reading for content. We have to be able to read this stuff and figure out what it means and how it applies to what we're doing. Okay, so look carefully at this problem then, and let's figure out what these two things are. Would anyone like to volunteer to tell me which, either one of those two, either the starting amount or the equality statement would be? The equality statement is what in the problem are two, what information in the problem tells you two things are equal. Yeah. Okay, what do you think the equality statement is?
44.0095 grams of carbon dioxide equals 1 mole of carbon dioxide.
Okay, it tells you that, doesn't it? It says that there are 44.0095 grams of carbon dioxide in a mole, and that means they're equal. Yes? The starting amount is 12.25 grams. That's the amount we're starting with. Okay? And that's what we're going to convert. You convert the starting amount. The equality statement is what you use to build that. Okay? So the starting amount then is 12.25 grams. And I'm going to use G here. Okay, I can shorthand it. What's the shorthand or the formula for carbon dioxide? CO2. All right, good. And the what? Well, we will when we get down here to build the problem. Right now we're just identifying the starting amount. Yes? Because the grams are grams of CO2, not grams of sugar or not grams of dust or something else. It's only CO2 we're talking about here, right? That identifies what we're starting with. The thing we're starting with is CO2. Okay? The equality statement is 44.0095 grams of CO2 is equal to 1 mole of CO2. Now I've shorthanded mole to MOL. The German word and the Latin word that we write MOLE is MOL. So that's kind of the shorthand. It's not much shorter, but it's the shorthand for mole. Okay? All right, now the equality statement is required. If you're doing a math problem in this class, for which you build a conversion unit, you must show me the equality statement. Okay, I want you to get that down till it's just like ingrained in your head. And you'll never have problems building conversion units from now on. Okay? Always know what the equality statement is and from the conversion unit, or if you have an equality statement, you can build a conversion unit. Always know what that is. Okay? So it's required that on the test, you write the equality statement for a problem. Got that? Understand? All right. So the way we build the problem is we start. We're going to build the problem now. And we're going to start by putting the starting amount over the number 1. And a fraction. And that's all we do. Put it over the number 1. Not 1 grams, not 1 milliliter, not 1 degree C, but 1. So we're going to say 12.25 grams of CO2 goes over the number 1. And that's how you set up your starting amount. Okay? Really simple stuff. Don't make it more complex than it is. All right? Then, after we do that, we're going to, yes?
Add it over the 1 and then what?
In a fraction.
Okay.
All right, then we're going to multiply by a conversion unit. We're going to multiply that starting amount. Fraction. Okay. Now the conversion unit is built from the equality statement. And it's a fraction. And the way you build it is the side of the equality statement that matches the units and species of the starting amount goes on the bottom. Yep, there you go. The side of the equality statement that matches the units and species of the starting amount. I should have put amount here. Goes on the bottom of the fraction. Alright, so I have the starting amount over 1 here. We're going to move that back down here because we need to start with that. 12.25 grams of CO2 over 1. And this is where we're going to build the conversion unit. Okay? So let me slide up a little bit here and let's find our equality statement. There's our equality statement right there. Okay? We want to look at our starting amount, and we have units of grams and a species of CO2. We want to find which side of this equality statement, the right side or the left side, matches this units and species of the starting amount. Well, this is the side that matches the units and species, right? This is grams of CO2. So by what I wrote down here, that part goes on the bottom. So that 44.0095 grams of CO2, the left side of the equality statement is going to go on the bottom of the conversion unit. And the other side of the equality statement, the 1 mole of CO2, goes on the top.
Is there a chance that it's like the other way around, like 1 mole is on the bottom?
Sure, you could have 1 mole on the bottom if our starting amount was in moles. Okay, so if my starting amount was moles of CO2, then I'd have moles of CO2 on the bottom here. You want the matching units and species to be on the top here and the bottom here. That makes sense? Okay. And the reason we do that is because it lets us cancel out the same way you can cancel x's and y's in algebra, right? So we can cancel G, or grams, because I've got 1 on the top, 1 on the bottom. If I had x on the top and x on the bottom, I'd cancel those out. Okay? I've got CO2, the species, on the top here, CO2 on the bottom here. So I can cancel those because it's just like x's and y's. If I had a y on the top here, I could cancel a y on the bottom. Right? So now we're ready to do